So anytime you are using any trig ratio, take note of the angle in consideration. The side that faces the angle in consideration is always the opposite. Is always the opposite. While the other angle will now be the adjacent, and the angle that faces 90 degree will be the hypotenuse. So that's the stand there. So quickly write this. Then we'll now look at Pythagoras theorem. So when you're done writing this, let me know.
What, sir?
Have you written the trig ratios?
Uh, I'm still writing it down,
All right. When you're done, let me know.
sir. Yes, sir.
Should be true. Hello.
Yes, sir.
Are you true with this?
Almost some of the I'm at the tell sign.
Okay.
Get done, sir.
Okay. Now, Pythagoras theorem. Can you state it?
Uh, a a squared plus b squared equals c squared, right?
Okay, that's the summary. But can you state it in statement?
Or opposite squared plus adjacent squared equals hypotenuse squared.
Okay. For all triangles.
For right angle triangles,
Ehen.
and then
Because that theorem does not hold for every triangle. So this is the appropriate way to state it. In a right angle triangle, in a right angled triangle, the square of the hypotenuse equals sum of squares of the opposite and adjacent sides. So that's how to state Pythagoras theorem properly. The key word there, in a right angle triangle, because the theorem does not hold for all triangles. Is that clear?
Yes, sir.
So I want to give the summary the way you have stated it. So the square of the hypotenuse, which is c squared, equals to the sum of opposite and adjacent. So this is the summary of it. So copy and complete that.
Yes, sir. I'm copying it.
Okay, when you're done, let me know.
You're done, sir.
Okay. Now, we are doing all this to form basis for what we're going to do later, which is what we want to start now. So let's now move on to the sine rule. Have you heard of that before?
Okay. Repeat that, sir.
Okay. The sine rule. So I'm going to give you a proof.
That sine,
That's what?
sine A would be
Okay. Yes.
B,
Yes.
And will be
But let me give you the proof of that. How the rule came into existence. Now, this one can be used for triangle that is not a right angle triangle. So suppose we have triangle ABC and you drop a perpendicular. You drop a perpendicular from C to line AB, and let's call that point D. You drop a perpendicular from C to AB and call that point where the perpendicular line meets AB, call it point D. So this place will be side C because it's facing angle A. This place will be side B because it's facing angle B. And the whole of this will be side C because it's facing angle C. Is that clear? Now, if you look at triangle BCD, that's a right angle triangle. So triangle BCD is a right angle triangle. So now from the trig ratio that we just looked at, I'm considering this angle now. Let me shade it with another color. We are looking at this side for now. So if you consider that, that's the right angle triangle, then I can now use trig ratio. So the angle in consideration now is angle B. All right? So this perpendicular CD, let's call it H. Let's call it H. So this is H. So since angle B is now the angle we are considering, that means H will now become our opposite. So this is opposite. And of course, A here is the hypotenuse in that context. And BD will be the adjacent. So opposite over hypotenuse. Those are the two parameters known. Opposite over hypotenuse, that will be sine B. So which implies that sine B equals opposite. Our opposite is H over hypotenuse, which is side A. So if you cross multiply, I want to make H the subject. So H will now be A sine B. H equals to A sine B. Let's call that equation 1. Are you with me?
Yes.
Okay. So similarly, let's consider, let me shade that with another color so that the thing will really make sense. So the side I'm shading in blue is the next triangle you want to consider. So, hello?
Yes, sir.
Yeah, I don't know, the thing is just logging out. I want to open the board now. So as I was saying, we now want to consider triangle ACD. So similarly, triangle ACD is a right angle triangle. Thus, so because this is also a right angle triangle, the angle in consideration now will now be angle A. Hope I'm communicating. So H will now be opposite and B will now be hypotenuse in that context. So sine A, which is now going to be opposite over hypotenuse, and our hypotenuse and opposite are respectively, or opposite and hypotenuse, that's H over B now. So this implies that H equals B sine A. Call this equation 2. Is that clear?
Yes, sir.
Okay. Now, don't forget, our aim is to prove the sine rule. If you look at equation 1, we have made H the subject there. If you also look at equation 2, we have made H the subject. So we can say that equation 1 equals equation 2, because in either case, H is the subject. Is that clear? Sorry, let me open the board again. Looking him, shaking it now. So ACD is a right angle triangle. Let me just quickly show you that again. This is D, A, B, C. No. So for the ACD, so the angle in consideration will be angle A. So sine A will be equals to opposite over hypotenuse. So sine A equals, the opposite is H now. The hypotenuse is B. So that implies that H equals B sine A. I don't know what is wrong with this service. That is just tripping up.